Hello class, it's time for another flip lesson. Today we're going to talk about solving two-step equations. We've already worked with one-step equations where you can solve an adding or subtracting equation and a multiplication or division equation. Now we're just going to combine those two into one equation. So we're going to write equation from picture representations and then we're going to solve those equations using the picture and algebraically as well. You should have a note sheet that you got in class, and you are going to copy any examples that we do, any example problems. You need to put it right in the corresponding slide that you see on your note sheet. That way you have some examples to look at when you try the problems on your own. So let's look at this first example where we have a balanced scale, and we have some blocks and rectangles on there, some squares and rectangles. We can't do anything unless we know what those represent. So we have a key, and we use that key to help us figure out what the equation is. I'm going to change the screen size so it's a little easier to read. We look at the key and we find the rectangle is x, the yellow squares are 1, and the red squares are -1. Now your paper is black and white, so you'll have to look at the shape and the shading to figure out which one is x, 1, and -1. When we do this, each part, each shape is a term in the equation. So your x's are going to be one term, and your units of 1 and -1 are going to be another term. And let's see if we can set up the equation. So we look at our first term, which is the x's, and we see how many x's do we have? Well, we have 2 x's. Then we look at our next term, and we have 8 ones. Now they're on the left side of this balance scale all together. So when you're thinking of all together, you're thinking of adding. So we're going to add those two together. That's everything that's on the left side. And it's an equation, so it has to stay balanced. That's what the equal sign means, is it's going to be balanced. And then we check for the right side of the equation. And we count up how many 1 units do we have, and we have 16. So your equation should be 2x plus 8 equals 16. So now we need to solve that equation. And we're going to use some of the methods that I taught you in class, which is to draw that straight line, the thing that I call the river, so that we have 2 equal sides and we keep everything lined up. First thing we need to do is we need to isolate the variable. We're going to isolate that x, but we do not start with the number closest. We start with the number farthest away. So that would be the 8. So we need to somehow remove that 8. Well, let's do this on the picture. If I want to get rid of the 8, I can just take them off the scale. But when I take them off the scale is no longer balanced. The left side is going to be lighter because I took some squares off of there. So to keep it balanced, I'm going to do the same thing to the other side. 2, 4, whoops, and 8. So I took 8 off. When I take 8 off of the scale, that is the same as subtraction. So I have subtracted 8 from both sides. So that's how we did it on the picture, and then we write it on our equation, and we just simplify, and we find that nothing changed with the 2x, and 8 plus -8, 8 minus 8 is 0, and 16 minus 8 is 8. So we have 2x equals 8. That's all that's left now. Looking up at our picture, we see we have 2x is equal to 8. So now let's go the next step. If we have 2x, we want to find out how much 1x is. The way we find out how much 1x is we have to divide out what's left equally to the x's that you see. So let's do that with the squares. Put one here, and we just keep going until it's divided evenly. And I want to know how much is 1x. 1x is equal to 4. But when we do that, so what we did is we divided it into 2 equal groups. And whatever it did to one side, we did to the other. And 2 divided by 2 is 1. So we have 1x left on the left side, and we have 8 divided by 2, which is 4. So x equals 4. So now we're going to check our answers. When we check our answers, we need to evaluate our equation. We've done this in class. It's similar to the M&M activity that we did. So we're going to plug in our answer. We said x is equal to 4. If x is equal to 4, that means if I put it back into my original equation, I should get 16. So 2 times 4 plus 8 should equal 16. 2 times 4 is 8, plus 8, 16, 16 equals 16. So we are going to start checking our answers to make sure we did it correctly. Let's try the next problem. See if you can take a moment and write the equation. Remember, x's are one term, and the 1 units and the negative 1 units are a different term. So I look and I see how many x's I have. I have 3x. And how many 1 units? Well, I have a negative 1 and a negative 2. Don't forget to use that key. Those are negatives. This is a negative 1 and a negative 1. And I add it together. And they need to equal, be balanced with what's on the right side. And there are 14. So that's my equation. 3x plus negative 2 equals negative 14. Now we're going to solve it with the picture, and we're going to solve it algebraically. So first we need to remove everything that is near the x's. We are going to remove those two. So I'm basically subtracting a negative 2. So thinking about that, subtracting a negative 2. Remember our additive inverse rule, the one where we use keep, flip, change to remember. I'm going to keep, flip, change. So this is the same as adding 2. So I want you to realize that even though we're subtracting a negative 2, when we write it, we actually write it as plus 2, adding 2. It's the inverse operation. But now we're not balanced, so we need to figure out, once we have 3x is equal to negative 12, we need to figure out how to get to 1x. So 1x, we'll divide out each what's left on the right side. I'm not actually moving them over there, I'm just grouping them so I can count. And I have divided them equally. And I have, for 1x, right here, 1x is equal to 4. So that's how we do it on the picture. Algebraically, we need to get this 3 to equal a 1. And the way we do that is we do the inverse operation, which is what we did on our picture. We divided it into 3 groups. So we are going to divide this by 3. And whatever we do to one side, we'll do to the other. Now you need to watch your signs. This is a negative 12 divided by 3, so we have to remember how to do our integer operations. And we have x is equal to negative 4. Negative 12 divided by a positive 3 is negative 4. So let's check our answer and see how we did. So we're going to take that negative 4, we're going to plug it in for that x, and we're going to see if we got the right answer. 3 times negative 4 plus negative 2 equals negative 14. Order of operations, we'll do our multiplication first, and we get negative 12 plus a negative 2, and that should equal negative 14, which it does, so we know we did it correctly. Let's try the next problem. We're going to write an equation. Notice that there's positives and negatives. This can be a little trickier, so we need to try every kind of problem. How many x's do we have? We have 3 x's. We have 5 positive ones, and we're going to add those together. Equal. And we have negative 4 on the right side. So we have 3x plus 5 equals negative 4. Let's solve it with the picture and algebraically. The problem with negative and positive numbers is I can remove 5 from this side. I can subtract 5 positive ones, but I don't have 5 positive ones to subtract from the right side of the equation. So I'm going to put up zeros in the form of our zero pairs. We talked about this in class. If I add a negative 1 and a positive 1, those two together are equal to 0. So I can put as many of those as I want up on the board, and it doesn't change the value. But I only need to put up 5 because that's how many I have. 1, 2, 3, 4, 5. So let's put up 5 zeros on this side. Let's move this out of the way. So there's 1. And there's 2. 3 zeros. 4 zeros. And 5 zeros. So I have 5 zeros. Now can I take away 5 positive ones, just like I did on the left side? I'm going to do the same thing to the right side. Now there's no way to show this when you solve the equation algebraically, that you put up zeros and you're taking some off, but you can see how it works with the picture. And then I just look to see what do I have left on this side of the equation. And it looks like I have 9 left. So I took off the 5 from the left side, and I am taking off 5 from the right side. And when I do the math, 5 minus 5 is 0, and I have 3x left on the left side. And on the right side, a negative 4 minus a 5. So it's negative 4 minus 5. Okay, and that's the same as negative 4, keep, flip, change. It's still going to be, like we did on the picture, a negative 9. So 3x is equal to negative 9. And again, we divide these into equal groups of 3. And we know when we do that, we end up with 1x is equal to 3. And in algebraically, we're going to divide by 3 to get the x by itself. So we have x is equal to a negative 3. Let's check our answer. Let's put that negative 3 in for x. 3 times negative 3 plus 5 is equal to negative 4. So we have negative 9 plus 5 is equal to negative 4, and that's correct. Negative 4 is equal to negative 4. So we're right. Let's try the next problem. Let's write an equation. We have 2x, a negative 3, and 11. 2x plus a negative 3 equals 11. Let's solve this. We are going to remove the negative 3, but just like the last problem, I have no negative 3's on the right side of my equation, so I'm going to put them on there in 0 pairs. So here's 1, 0. Here's another 0. And I only need 3 of them because I removed 3 from the left side. So now I've added 3 zeros. And that means that I now have 3 negative 1's that I can remove just like I did on the left side. So that's the same as adding a 3. And then we just simplify to see what we have left. Left side, 2x. Right side, 14. And then we can divide those into equal groups. Figure out how much 1x is equal to. Or we can do it with algebra by dividing by 2. So we have x is equal to 7. Let's check our answer. 2 times 7 plus a negative 3 is equal to 11. So we have 14 plus negative 3 is equal to 11, and 11 is equal to 11. So it worked. Let's write another one. See if you can do this one on your own. I will start you off with the equation. You do not have to do the picture. Obviously, you're at home, so you can't move your boxes around. But go ahead and try to solve this as 4x plus 5 equals negative 11. Another way to look at this representation is just to use a cup and put all, instead of having those little 1 squares, we'll just have a cup that tells you how much you have. So in this case, we have 12 is equal to 3x minus, oh, I have that backwards. 3x plus negative 3 equals 12. My picture is backward. Actually, I should have flipped the left and right side, but we'll go ahead and solve it this way. So you don't really have to move anything on your balance scale, but we have a negative 3. Remember, we work away from our variable towards our variable. So I do the inverse. And the inverse of adding a negative 3 is adding a positive 3. That'll give us 3x is equal to 15. Divide those by 3 because we want to get the x by itself. So we have x is equal to 5. I'm going to check my answer on this one. 3 times 5 plus a negative 3 is equal to 12. 15 plus negative 3 is equal to 12. So we do have 12 is equal to 12. It is correct. All right, fractions. I know how much we love fractions, and we do need to talk about how to do this with an equation. Everything is the same as what we've done so far. I have an equation of 1/4 x plus 5 is equal to 8. I need to eliminate my 5, so I subtract 5. And then I'm left with 1/4 x equals 3. So this is what you already know how to do, how to remove the adding and subtracting part of your equation. But now I have this fraction, and I need to remove that from the x. And I'm not really removing it, I want it to equal 1. So looking at that fraction, 1/4, what can I multiply that fraction by to get an answer of 1/4? Let's see, if I have 1/4, I want to multiply it by something, and I need it to equal 1. The reason I want it to equal 1 is 1 times x is x. Anytime you multiply anything by 1, nothing changes. So I can multiply this by 4, because that is equal to 4/4, and 4/4 is equal to 1. So if I multiply it by 4, I do that to both sides of the equation to stay balanced. We know that 4 times 1/4 is 1, so that's 4/4 x is equal to 12, and 4/4 is equal to 1, x is equal to 12. 1x is equal to 12. And remember, we don't usually write the 1. If you do write it, it is not wrong. Let's try it with 2/3. So what can I multiply 2/3 by? Times something, and I need it to equal 1 again. Whenever we do that, we just multiply by the reciprocal. So we're going to multiply it by 3/2, because we multiply straight across. 6 straight across over 6 is equal to 1. So everything stays the same. To get rid of the -7 or the -7, we add 7, inverse operation. And we're left with 2/3 x equal 18. And now we're going to multiply by 3/2, because 3/2 is equal to 6/6x. And on this side, again, we multiply numerators and denominators, and this one is a 1. And we get 54 over 2. And we can simplify that. 54 divided by 2 and 6 over 6. So we get x is equal to 27. So really, you're just thinking about reciprocals. Whenever you see those fractions, think reciprocal, flipping that fraction. So here are 2 more examples on how to do the fractions. So whenever you have x over 4, this is the part I want you to rethink. Think about that. Can I write that another way? X over 4 is equal to 1/4 x. I'm just pulling that fraction out, and then it becomes just like the problem we did in the last example. Another way to think about it is this is the same as x divided by 4. So the inverse operation of dividing by 4 is multiplying by 4. So you're going to still solve it the same way we did on this problem. It's exactly the same thing. You're multiplying by 4, but it's just 2 ways to look at a fraction that looks like this. You can look at it as 1/4 x, or you can look at it as dividing by 4 and then doing the inverse operation. So the answers will still be the same. Okay, you need to do the remaining problems as your homework and bring them to class when we come back to school, and we will go over them and practice some more. Have a wonderful evening.